Hello, so I'm going to have a look at condensation polymerisation, something that was always traditionally on the A-level specification but is now on the GCSE. It's not that difficult, but some people do take a couple of goes round to get to grips with it, so feel free to play the video more than once. Okay, right, so previously we looked at addition polymerisation. Now that is when you add a carbon double bond, and then when you're building your chain from your monomers, you end up with a single carbon bond. Okay, so addition polymerisation from your monomer with a double bond went to a single bond. So when you form your polymer chains, double bond changed into a single bond. Right, okay, condensation polymerisation is when you've got the making of a chain, but you've got it from two different functional groups. So for example, if you take carboxylic acid and you combine that with an alcohol, okay? Condensation, the word comes from the production of water in this example. Now in this you don't need to know the formulae, okay? You just need to be able to explain the basic principles of condensation polymerisation and refer to the functional groups. Right, okay, so let's show you how this works. Here we've got an alcohol, which is ethane diol, and here you've got carboxylic acid, which is hexane dioic acid. Okay, neither of which is on the specification, but you should be able to figure out how condensation polymerisation works. Right, the great thing about chemists is we're looking to take the easy way of doing this. So, because we're only interested in the two different functional groups, we can sack off these bits in the middle. And we do that by putting a box in. Not interested in this, so bye to that. Same for this bit, not interested in the middle, so get rid of all that. We're only interested in the functional groups. Okay, and because this is a diol, there's two functional groups of the alcohol, and because this is a dioic acid, there's two functional groups of there. Nothing that you need to be aware of until you get to your A-levels. Right, okay, so we're going to produce water. Where does the water come from? Okay, it comes from the H's there, so they disappear, and it comes from the HO there because it's H2O. Okay, so H, 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 O, H, O. Okay, so we've got 4 H's and 2 O's. Okay, so that means that we're going to end up with 2 lots of H2O. So that's our condensation polymerisation. What's the other product? The other product is what is left. Okay, so we end up with O, box, because we're not interested. We end up with CO, or OC, doesn't really matter which way it goes round. Box, CO, because we've sacked off the water out of this and made this separate product. Okay, so because it's a polymer, put brackets around the polymer. We represent that with lines either side, and we put an N at the bottom to represent that we can make this more than one. Okay, so there could be multiple of these, there could be multiple of these, and of course for every single one of those there's going to be that as well. So in approaching condensation polymerisation, write it out. Okay, maybe the boxes will be given to you, I don't know. Okay, write it out, circle the H's, circle the OH's, figure out how much water you're going to make and what is left, get rid of the circles, and that's your polymer. Okay, it used to be on A-level. I don't think it's particularly difficult, but it might need a couple of goes round for you to have a look and see what you've done. If you're not sure, go back for a few lessons to carboxylic acids and look what I said about esters, because that's condensation polymerisation as well.